The landscape pictured here is part of the rolling countryside of Wisconsin, and the procession, advancing so steadily across the hills, is engaged in a most unusual operation. In fact, the operation is making communications history. It is one involving plowing and planting, as is appropriate in a land of pleasant farms. But the plow behind the 95 horsepower tractors is far different from those that usually break the soil of farmlands. This plow makes a slit in the earth deeper than ever before attempted with equipment of this kind, a full 30 inches and often deeper, and the opening immediately becomes the resting place of a telephone cable that unwinds from its sturdy reel as the procession moves ahead. The history-making aspect of the event is this, that the sections of cable here being buried are part of a newly developed system of transmitting human speech. It is called a coaxial cable, and this installation, partly underground and partly overhead, for 200 miles across the friendly Wisconsin countryside, is the first of its kind in America to form a part of the country's long-distance network. The whole episode is an example of scientific research and engineering teaming up in this modern day to meet a communication need. The engineering aspects of the story are explained by the map of long-distance lines serving the Northwest. A network of telephone cables has been growing with every year, so that important long-distance channels might have extra protection from the hazards of wind and sleet. More of these cable circuits to the Northwest was the demand on the engineers. And in this new coaxial cable system, science has provided the needed circuits in a most astonishing manner. It's a very different cable from the usual lead-covered collection of separate wires. There are separate wires, but those for long-distance conversations are to serve intermediate points along the route, and the others are needed for the maintenance of the coaxial system. The distinctive feature of this cable is the use of coaxial conductors, which the splicer is here showing the photographer. Before looking at them more closely, let us note the expert skill required to join two sections of cable together. Each of the four coaxials consists of a tube as an outer conductor, with a copper inner conductor down the middle. The word coaxial simply means that the tube and its inner conductor have the same axis. The tube is only as large as a lead pencil, many times smaller than a long-distance cable with hundreds of wires. Yet it will transmit just about as many telephone messages. To be specific, two of these coaxials, one for each direction of transmission, will permit as many as 480 telephone conversations simultaneously. In other words, these conductors will do the work of a full-size toll cable with hundreds of copper wires, and that's certainly saving a lot of copper. On the screen before you is shown the electrical apparatus that makes possible this multitude of non-interfering spoken messages. This apparatus is the result of discoveries and inventions during a period of nearly 3 decades in the development of what the telephone scientists call carrier current systems. It is a fascinating, complicated electrical creation, utilizing vacuum tubes, quartz crystal filters, copper oxide modulators, transformers, and other components of today's communications art. This is the complex apparatus installed at each terminal of the cable. Its operation is too technical to describe here in detail. Its function, however, can be suggested by means of a simple illustration. Imagine a system of mail chutes that converge at a common outlet, where individual written messages are delivered to a conveyor that then takes them to a distant point for sorting and distribution. Somewhat comparable to such a system is the coaxial telephone system. It transmits electrical waves representing spoken messages by combining them into a composite wave, which is conducted to a distant terminal for an electrical sorting and distribution. This astonishing application of modern communications science is made possible through the magical art of amplification. On a transcontinental voice journey, for example, the voice current is amplified on the average about every 100 miles, so that our speech reaches far distant telephones clear and distinct. Since there are separate amplifiers for each wire circuit, and since there are often hundreds of these wire circuits on a single route, it is necessary to have special buildings known as repeater stations in which to house the amplifying equipment. But the new coaxial system does not involve separate wires as voice channels. Instead of wires, it uses carrier waves, and so the telephone scientists had the problem of perfecting a device that would amplify a composite wave made up of 480 voice currents. And here's one of the structures containing the answer to the problem. It shelters the most amazing amplifying apparatus ever designed or manufactured. There's a 6-tube amplifier associated with each coaxial conductor. It amplifies the energy some 20,000 times. Moreover, this amplification is needed every 5 miles, and yet the composite voice wave transmitted by the conductor is accurately preserved in every characteristic. And the 480 individual waves, which traveled as one, will properly reach telephone receivers to be again converted into speech. In fact, it is the perfection of the amplifier that makes the coaxial system such an outstanding communications achievement. The performance of the amplifier seems all the more amazing when we examine the amplifying tube in detail and note the delicate elements that must be assembled with such scientific precision in order to work their magic. Unusual skill and painstaking care are required in its assembly. The filament, for example, is finer than a human hair. Even a microscope must be used to be sure that there will be no flaw in this masterpiece of electronics. Thus, to the arts of research and engineering must be added that of the precision manufacturer as we explore the details of the coaxial cable system. And there is still another art, that of making the cable itself. Many unique mechanical processes are involved. First comes the stamping of the insulating discs that will separate the inner and outer conductors of the cable. Over 65 millions of these discs are required for the 200 miles of cable that this motion picture describes. And here are the ingenious machines that form the coaxial conductor itself. The first step is to attach the insulating discs to the wire that will become the inner conductor of the coaxial tube. Perfect mechanical timing results in perfect spacing, as these pictures show, and prepares the wire for the operation that makes it part of a coaxial conductor, an operation that transforms a copper tape into a tube to surround the inner wire. A wrapping of steel tape around the tube is the next process in this cable-making technique. And then comes one of the many electrical tests that ensure a proper functioning of the cable when in operation. An important part in the manufacturing routine is played by the machine that twists 4 coaxial tubes into one unit, while at the same time adding some of the additional wires that have already been mentioned. When this combination of tubes and wires has been given a wrapping of paper, more wires are added for other uses, and then another paper wrapping is applied. More tests must be made before the cable is ready for its sheathing of lead. After protective coverings are added to this leaden sheath, a final test shows no defects that will prevent the cable's electrical performance, and it is ready for its task. So it is that many arts and many skills have given telephone men a new circuit structure and a new technique in making this structure an agency of service. The peaceful herds will graze again where the cable caravan crossed the landscape. Over the plow's deep path, the winter snow will drift, or ripening grain will bend to the fragrant wind that cools this northwest land of lakes and farms. But underneath, 30 inches down in the rich, sustaining soil will be channels for the speeding words of men. Truly the good earth, when the words are of friendship and of peace.